Okay, today we will discuss about atmospheric pressure. Okay, what is atmospheric pressure? Okay,
Okay.
so because the name is atmospheric means because of atmosphere.
Atmospheric.
Atmospheric means because of atmosphere, we are feeling the atmospheric pressure. Okay, so our earth. Okay, you know our earth is like this is our earth. Okay, so above our earth, okay, up to 300 kilometer, the atmosphere is surrounding our earth. Okay, like say we can say completely up to 300 kilometer. 300 kilometer. This is huge, you know. Our aeroplanes are flying at a altitude of nearly maximum up to 25 kilometer. Okay, so up to 300 kilometer there is atmosphere. Okay, above our earth surface. Okay, so this atmosphere, as you know, earth atmosphere has different gases. Okay, what are those gases? No liquid. I am talking about the atmosphere has air. Okay, so this atmospheric air contains different type of gases. Okay, you have studied it has 78% nitrogen. Okay, it has around 20% oxygen, and the remaining other gases like carbon dioxide, carbon monoxide, and many other gases. Okay, so atmosphere contains different gases such as nitrogen, oxygen, carbon dioxide, carbon monoxide, and many other
gases.
Okay, so so this gas or air, it has its own weight. Okay, so you know there are three different types of substances. You know, you have solid, you have liquid, and you have gas. Gas is nothing but your air. Okay? So you know the solids have higher density. That's why solids are heavier. Okay, liquid have comparatively lesser density than solid. So for a given volume of solid and liquid, you will find a solid to be heavier. Okay, for a given volume. So let us say 1 liter of
Water.
1 liter of water, if you compare with 1 liter of say iron, so iron will be heavier because solid is more dense. Okay,
Because iron is solid and water is liquid.
Okay, so similarly you have gas. Okay, so gas is density is much lesser. Okay,
Like air.
Okay, so so because of the weight of the atmosphere, you will feel some pressure. Okay, so this is our earth. Okay, so surrounding the earth you have the atmosphere up to 300 kilometer. Okay, so surrounding the earth you have the atmosphere up to 300 kilometer, which is your atmosphere. Okay, so this atmosphere, because of its weight, okay, it will exert some pressure on all of us. Okay, so the definition of atmospheric pressure is the pressure exerted on us, every one of us who are on the surface of earth, the pressure exerted on all of us because of the weight of air. Okay, weight of air, that is called atmospheric pressure. So we will like for your class, whatever the atmospheric pressure is, like you just imagine you have this kind of a cuboid. Okay, so like this. Okay, okay, so you just imagine this particular cuboid has the base has a surface area of 1 meter square. That means its length is 1 meter this is 1 meter, and its breadth is 1 meter.
1 meter.
So on this 1 meter square area, okay, so you have you imagine that this is kind of a vessel, okay. So inside this vessel you have air, okay. So this is filled with air, okay. This is filled with air, okay.
Okay.
So as you know, the density of air is comparatively higher near the earth. As we go up, the density of air will decrease, okay. So this particular vessel, this is denser air, okay.
Okay.
This is denser air. As we go up, the density will be comparatively less. So this particular so I am putting less dots at the top because density is comparatively less. At the middle I am putting little more dots, okay. As we go up, the density is, what is density? Density is nothing but number of air molecules.
Number of air
So you have
molecules.
more air molecules. You have more air molecules near the surface of Earth. As you go up, you have lesser air molecule. As you go up, you have still lesser. Okay. So you imagine that on a area of 1 meter square. So this is the area of the surface. On 1 meter square, you have a air column standing. So this total air column is exerting some pressure on 1 meter square area. So that is what, like say, we have studied that the pressure, atmospheric pressure is highest at sea level. Okay. So let us say this is your sea. Okay. So you have completely you have the atmosphere standing on this, exerting. The atmosphere is because of the atmosphere is exerting its weight on the on anyone standing on the sea level. Okay. So let us say this is your sea level. Okay. Sea level. Okay. Understood? This is my sea level. Okay. On this sea level, I have the atmosphere. Okay. So anyone, let us say a human being, okay, he is standing here. So he is feeling the weight of the atmosphere, and because of that, atmospheric pressure is exerted on the person standing on the sea level. But as this person goes up and up, the height of air goes on decreasing. Right? So let us say let us say somebody is climbing Mount Everest. So what is the height of Mount Everest?
8,898.
So 8,848 meter or so, right? So something around 9 kilometer. Okay. So when this person, like say, let us say this is Mount Everest. Okay. This person is, let us say, he is climbing. Okay. So he is going up and up. So when he is climbing, when he is going to a height of around 9 kilometer, so when he is going up, yeah. So when he is going up, the pressure of the weight of air goes on decreasing, because as we go up, the height of air goes on decreasing. The height of air, as the person goes up and up, it goes on decreasing. Okay. So that's why as when someone is at the sea level, the pressure is highest. As we go up and up, the amount of air which is exerting pressure on us, it decreases, because as we go up and up, the amount of air, like earlier we have this much of air. Okay. Now when I am going up, I will have less air. Okay. So when I have less air, the weight is less and the pressure exerted is less. Okay. So that is what is atmospheric pressure. So atmospheric pressure is because of the weight of air exerted on us. Okay. And as we go up, the pressure decreases. So there can be a question, as the altitude increases, what happens to pressure? As altitude increases, the pressure decreases. Okay.
Okay.
See, we will see some like what is the value of atmospheric pressure. Okay?
Value of atmosphere.
Value of atmospheric pressure. It is measured by a device called barometer. Barometer. So what is barometer? So barometer, it is a device. It is a device to measure atmospheric pressure.
Parameter.
Yeah. Okay.
Okay.
So, so how does a barometer looks like? You just imagine you have a vessel now. Okay.
Vessel.
So
Okay.
this is, and you have a tube. Okay. So you have a tube. Okay. So one end of the tube is open. Okay. And then no. So you fill up this particular vessel with mercury. Okay. You fill up this particular vessel with mercury.
Mercury.
Okay. And then you fill this tube with mercury. Like say initially let us say the tube is like this. Okay. Okay.
Okay.
So you fill it with mercury. Put your thumb on the open side and make it upside down. Okay. So when you make it upside down, so let us say now this is your tube. Okay. So this and outside the tube you have atmospheric pressure acting, right?
Yeah.
Outside the tube you have the atmospheric pressure acting. Okay. Then this mercury will rush inside the tube because of the atmospheric pressure. Okay. So because this side is open. Okay. This side is open. So this is the tube. So this mercury will rise to certain height. Okay. This mercury will rise to certain height. So what is that height? That height, typically in a barometer you will find this height, let us say up to here. So this height you will have a scale and all. Okay, you can measure. Okay, so this height will be coming out to be 760 centimeter or 760 mm. Okay, so that's why like atmospheric pressure is equal to 760 centimeter of mercury, sorry, 76 centimeter of mercury or 760 mm of mercury. Okay. So, so there may be a question like, why you use mercury? Why don't you use any other liquid? Let us say milk or water or oil. We use mercury because mercury has the highest density. Highest density. So because it has highest density, it will not rise. If you put other liquid, it may rise to higher height. Okay, which will be difficult to, like, it will not be manageable. Okay, so mercury has the highest density among all the liquid, which is 13.6 times heavier than water. Okay. If the density of water is 1000 kg per meter cube, the density of mercury is 13,600 kg per meter cube. So that is why in a barometer we use mercury. And 1 atmospheric pressure is equal to
760.
Yeah. 1 atmospheric pressure is equal to 760 mm of mercury.
Hg. That means Hg.
Hg. Okay. So this is, or you can write it as 760 centimeter of mercury. Okay.
Okay.
Okay. Now you understand? You
Okay.
can, like, this is here in this
Water.
You have, no, this is
Vessel.
mercury. Everything is mercury. This is called Hg or mercury. Okay. This is the vessel. Inside this you have kept mercury. This mercury is rising, and here you have vacuum. You don't have anything. Okay.
Okay.
At the top you have vacuum.
Vacuum.
Okay. The mercury column has a region up to this side. Okay.
Okay.
Up to 76. Put the arrow here. Okay. Okay.
Okay.
So this is the barometer is a device which is used to measure the
Atmospheric
pressure. Okay. And the value of atmospheric pressure is
760
mm of mercury. Okay. And one more thing you just remember, you remember that pressure is written as pressure is equal to H rho G. Okay. So
H
is height of mercury column. Okay. H is height. Okay.
Okay.
Height of mercury column. Okay. Column. Okay. And rho is density of mercury. Okay. Density of mercury. Okay. Then G is acceleration due to gravity.
Gravity. Acceleration due to gravity.
Okay.
Okay.
So just remember how we calculate the pressure. Like say we have told, like say this is my tube. Okay.
Okay.
Now we saw that the atmospheric pressure is equal to H is equal to 760 mm of mercury. Okay. So how I calculate how much is the atmospheric pressure in Pascal? If I want to calculate in Pascal, P atmospheric is equal to H rho into G. So
G.
H is here 760 mm. Okay, 760 mm. So if I want to convert mm into meter, I have to divide by 1000. Okay, 1000 meter. Okay, and then the density of mercury is, density of water is 1000 kg per meter cube. Just remember. Okay, 1000 kg per meter cube.
Per meter cube.
Okay, so mercury density is 13,600 kg per meter cube. Okay.
Okay.
Because you are using meter unit for height, you have to use meter unit for density also. Okay, this is density of mercury because you want to measure atmospheric pressure. So 760 divided by 1000, then density of mercury is 13,600 kg per meter cube. Okay. Okay. And G is nothing but 9.8 meter per second. Okay. So so now you have, this is kg meter per second square. These three things together is called Newton. Okay? This is called Newton. Okay. Kg meter per second square. So 1 Newton is equal to 1 kg meter into meter per second square. So what is Newton? Newton is a force which gives a 9.8. Newton is the force which gives 1 meter per second square acceleration to 1 kg mass. Okay. So force is equal to mass into acceleration. So that's right. So 1 Newton is, so kg meter per second square become Newton, and this is meter. This, if you cancel, it become meter square. So the unit will become Newton per meter square. Okay.
Okay.
So finally, if you multiply and simplify in terms of Pascal, P atmospheric pressure will come 103 kilopascal. Okay. Which is nothing but 103 zeros. Pascal. Okay. Newton per meter square. Or you can write it as 1.03 into 10 to the power 5 Pascal. Okay. So just remember, atmospheric pressure is equal to 103 kilopascal. Okay. So how big is this atmospheric pressure? This atmospheric pressure is very big. Okay. How will say that atmospheric pressure is a big number? See, we told now atmospheric pressure is equal to 103 kilopascal. Okay, which is 103 thousand. Kilo means thousand. Okay, 3000 pascal. Okay, which is equal to 103,000 Newton per meter square.
Meter square.
Okay, now you know that 1 kg is equal to 1 kg force is equal to 10 Newton. You have studied. Okay,
Yes.
that means you just divide this value by 10, so it will become 103,000. 1 0 will go. Okay, like 103,000 Newton per meter square. If you divide it by 10,
10.
it will become,
Zero.
if you divide 103,000 kg force.
kg force.
Kg force per meter square. Okay,
Okay.
so 1030 kg force, that means it is 10,000 kg force. So let us say you have this board, what you are seeing, it is a 1 meter square area. Let us assume, like say 1 meter square, like let us say this is both sides 1 meter, 1 meter. Let us say this is 1 meter. Actually this is not 1 meter. Your board is, your length is 1 meter, breadth is 1
1
meter.
meter.
So it is 1 meter by 1 meter. So on 1 meter by 1 meter square area, if you have 10,000 kg, 10,000 kg means what? See, one elephant weight of one elephant weight is 1,000 kg. Okay.
Okay.
See, let us say your weight is 100 kg. It is not, your weight is 60 kg, but let us say your weight is 100 kg. An elephant weight is 10 times more than you, which is 1,000 kg.
1000.
But this is 10,000 kg. That means on an area of 1 meter square, on this board, if 10 elephants stand, if 10 elephants standing on 1 meter square area on this board, the kind of pressure they will exert, that is atmospheric pressure. That means it is a huge pressure.
Huge pressure.
10 elephants standing on 1 meter square area. Okay. 10 elephants standing, just think that your body, you are sleeping, your body has a area of 1 meter square. Assume that your body has a area of 1 meter square. And 10 elephants are standing on your body. The kind of pressure you will see, that is atmospheric pressure. Okay. Then you will ask, if so much of pressure atmosphere is exerting on us, then why we are not getting crushed? Or if 10 elephants stand on us, we will immediately get crushed and die, na? So why that is not happening? Because inside our body, there is, internally we have a pressure which is balancing the atmospheric pressure. Okay. So there can be a question like, why do we bleed? Why our nose starts bleeding when we go to, like say when we are climbing Mount Everest, or when we are climbing a hill, sometimes our nose starts bleeding, because when we go up, the height of air which is exerting pressure on us, that decreases. Okay. We had a study, like say this is a water vessel. Okay.
Yes.
So you have, let us say, 3 points. Okay. Let us say A, B, C. Okay. And you have water. Okay. And so at point C, pressure is highest, because the height of water above point C is the highest. So pressure at C is greater than pressure at B is greater than pressure at A, right? Because this is the lowest point. So likewise, at sea level, atmospheric pressure is highest. When we go up, pressure decreases. So when we are climbing a hill, the height of air above us slowly start decreasing, pressure decreasing. So outside pressure is less. So when the outside atmospheric pressure is less outside, our blood vessels in our nose, they may rupture.
When the person is going to climbing up Mount Everest, they'll start bleeding.
Because the outside pressure is less, inside pressure is more. Our blood vessel will rupture and it will bleed.
Bleed.
Okay. So that also there can be a question. What about the atmospheric pressure in the surface of moon? Just remember, there is no air in moon, so atmospheric pressure is zero in moon. Then there will be a question. Then how the people are going to moon? Why they are not bleeding, or why their blood vessels are not? Yeah, they are using a special dress for astronauts.
Astronaut.
There are special dresses
Because it is
That is
safety
kind-
for us.
yeah. So what is there inside that dress? That dress has a special provision to completely it will pressurize our body. Okay, it will squeeze our body and pressurize our body. So a artificial pressure is created on our body when we are on the surface of moon. That's why we are not bleeding. Okay.
Okay.
So the astronauts are wearing special dresses
Special dresses.
so that it will pressurize the human body,
Human body.
even though there is no atmosphere. So human beings will not bleed even if there is no atmosphere on the surface of moon. Okay, so there is no atmosphere on the surface of moon, but on the surface of Jupiter, on the surface of Venus, there are atmosphere. Atmosphere means in Jupiter there is mercury, in Venus there is carbon dioxide. They are heavier than our atmospheric gases. So pressure in Jupiter is much more. They have as compared to what it is on the surface of Earth. Okay.
Okay.
Now you understand
Yes.
what is atmospheric pressure?
Pressure.
To summarize, I am telling atmospheric pressure is pressure exerted on us, okay, because of the weight of atmospheric air. Okay, 1 atmospheric pressure is equal to 760 mm of mercury or 103 kilopascal. Okay, to give a order of magnitude of atmospheric pressure, it is as good as 10 elephants standing on an area of 1 meter
1
square,
meter square.
which is 103 kilopascal.
Square.
Okay, it's a huge, and there can be a question like, why do we start bleeding when we are climbing?
Because person is climbing on
When we are climbing,
because
the atmospheric pressure is less, so there is
the
a
pressure
chance.
is more.
Inside pressure, body pressure inside is more, atmospheric pressure is less.
Less.
There is a chance of our blood vessels rupturing,
Okay.
which can
start
cause
bleeding.
bleeding. Okay, that is one more example of atmospheric pressure. Okay.
Okay.
So now you know the order. And barometer. What is barometer? Barometer is a device used to measure atmospheric pressure. Okay. Okay, that's all.